life in physics. So we just replace the X with R. Okay, so I believe that you've enjoyed. So remember the negative sign, because there's the meaning. The negative sign shows that will be telling you that the gravitational potential, negative sign, the gravitational potential at the surface of the S is less than that at infinity. That is what. So gravitational potential at the surface of the S is less than the gravitational potential at infinity. The work done required to remove a body from the point to the point is less than the work done required to remove a satellite from the infinity to the point. So now, because we know the work done required to bring a satellite from the point or from the infinity to the point, then now, because I've talked about gravitational field, I've talked about gravitational field strengths, I've talked about the work done required to bring a satellite from the infinity to the point, and right now I would like to teach you once again another concept which I mentioned on the title of today's lecture. That is called the gravitational potential. Not gravitational potential energy, I will teach it to you later, but I'll have to teach you gravitational potential. Make sure that you know the distinction between those terminologies. They are completely different. So allow me to teach you the concept in gravitational potential. So gravitational potential. And this, the notations is V in most of the books. Some of the books they use U. Say gravitational potential. Gravitational potential. In electrostatic, I'll teach you about the electrostatic potential, which we call the latence. We used to call the electrostatic potential latence, we call potential difference, which is the driving force of electric current. Okay, so that's what we say. So what is gravitational potential? Okay, so the basic fundamental question, what is gravitational potential? What is gravitational potential? That's the question that we have on the spot. Is a point in gravitational field found some definition. We say that gravitational potential is a point in a gravitational field, that is defined as the mounting of work done in bringing the body of unity mass body of unity mass from infinity where the potential is 0, where the gravitational potential is 0 to the point. So that's the definitions of gravitational potential. Gravitational potential, we say that is a point in gravitational field, is one of the points in the gravitational field that is defined as amounting, is the amount of work done in bringing the body, for example, a satellite of a unity mass from infinity, where the gravitational potential is 0, because I told you it's outside or it's away from the gravitational field of the Earth, okay, is 0 to the point. So that's the definitions of what the gravitational potential. So we say that the notation of gravitational potential, is V in some of the books. Okay, in some of the books. Example, Principle of Physics by Newton, simply call it Newton, and Chandy, they use that symbol, and Chandy 1, this is S Chandy, Principle of Physics, and also, and U in some of the books, for example, in rhodium and Castor, shapely quality in rhodium. So this gravitational potential V, now we say mathematically, can be defined mathematically. We say that gravitational potential, not gravitational field strength, gravitational potential, not gravitational field strength. Gravitational field strength is the ratio of 40 force to what? To the mass of the body. Gravitational potential V, let us in this note or in this lecture we'll be using V as an additional gravitational potential, which will be given as work done over mass of a body that will be brought from the infinity to the point. So it means that if that's the case now, we say that from the formula, that the mathematical formula that the work done is equal to negative mass of the body that has been brought from the infinity over the radius r. So then now we can define gravitational potential is equal to work done, according to the formula there, over mass. So this work done is equal to the mass of the body times mass of the S, gravitational constant. So remember that these are the lower cases. Then divided by mass of the body, then we have radius. So mass and mass will cancel. So we say that gravitational potential is negative to indicate that the gravitational potential at infinity is higher than the gravitational potential at the point. So then now we say that the general formula for the gravitational potential, the mathematical formula, will be negative mass of the S times universal gravitational constant, and then we divide by the radius r. So this is the formula of gravitational potential. Again, we can be asked to find the dimension of gravitational potential. This is not potential difference, please. This is not potential difference that you've been learning in current electricity. No, that is, we call it gravitational potential for gravitational mechanics. It's a very important physical quantity. So you have to be careful. Don't call this the potential difference. No, this is called gravitational potential, not potential difference. Take care about that. So the SI unity, of of the gravitational potential is joules per kilogram. Because you say gravitational potential, mathematically is a ratio of work done brings a body from the infinity to the point to the mass of the body. You can find the dimension. Okay? It's very simple for you, who have been teaching you. So we have some few points that to note. Number one, we say that the gravitational potential, when you understand this subtopic, gravitational potential, you will easily also understand electrostat because you have a similar subject like this. Okay? So the gravitational potential, V, is always, so this is number one is always negative. You can never find gravitational potential as the positive number or integer. Number two, we say the gravitational potential is a scalar quantity. This is very important. Remember, the gravitational field strength is the vector quantity. The gravitational potential is a scalar quantity. It's a scalar physical quantity. So it has only magnitude, a scalar physical quantity. It has a scalar physical quantity, or it is a scalar physical quantity. You enjoy the beauty of gravitational potential? When you be doing your private study, then you can call that the potential difference, which is not true. Then the third note, we say the negative sign in the formula of gravitational potential indicate that the gravitational potential at the Earth's surface, is less than the gravitational potential at infinity. Then, if that is all about gravitational potential, I would like to take you to the next step when I'll be teaching you the derivations of the formula of relationship between gravitational potential and the field strength, so gravitational field strength, gravitational potential and gravitational field strength. So let's go to the derivation of gravitational gravitational field strength the relationship not revision of the formula, or minor correction. Revision of the formula of relationship between gravitational potential and the gravitational field strength. So gravitational field strength. So what is the relationship between these two phenomena? Okay. So let us go to the business. I've told you. So the first state, recall the formula, mathematical formula of gravitational field strength. Gravitational field strength A. I told you that gravitational field strength is equal to the work done over, it's a ratio of force to the mass of the body. So suppose that this is the first equation. Then we go for the second state. Recall the formula called the formula of gravitational potential. Gravitational potential V. So the formula of gravitational potential V, we say it is work done over mass. Right? So then, if we make work done the subject, we find that this is equal to mass times gravitational potential V. Right? Times work done is equal to, because it's a gravitational potential, yes, over mass. Okay, for this first equation, we can make an equation like this that make force the subject. So force is equal to gravitational field strength times mass of the body. So this is the first equation. Then here we have work done is equal to mass times 30 times mass of 40, but this should be negative. Gravitational potential should be negative. So suppose that this is negative sign, or the work done is negative like this. So this is the second equation. That. Then I told you that in gravitation, or even in mechanics, or in fundamental physics, you say work done is equal to force. So this is the steady state is equal to force times 30 times distance. Force times distance. So the distance there, suppose that because you want to find this relationship when the distance and even the potential, gravitational potential is very small. So suppose that we want to find the small change in work done. So you say this is equal to the force times small change in distance, let's say dr. Right? Dr. So if that's the case, we say that, okay, fine. So then we say that, if you recall, we say that now, change in work done also, so this is equation 3. According to this equation, means change in work done also is equal to negative, if you divide by negative both sides, mass times small change in what? So this small change, we say that dV. Right? So this is equation 4. So we say that a small change in work done is equal to negative mass times small change in what? In gravitational potential. So we can go to the first step. The first step, we can equate equation 3, means you can equate equation 3 and equation 4. Be careful in these derivations, my dear student. Okay, so if you equate them, we say that this is negative mass, and hence times gravitational potential is equal to the force times dr. Again, we have equation 1. So we can replace force with equation 1. Okay? So we say that, mean that, but we have force is equal to gravitational field strength times mass of the body. So we have negative mass times small change in gravitational potential. Then here we have gravitational field strength times mass times dr. So mass and mass will cancel. So negative gravitational potential is equal to the gravitational field strength then times dr. So divided by dr and then divided by dr. So then now the relationship between gravitational field strength and the gravitational potential is given as small change in gravitational potential of a small change in distance r. Very important expression. I will teach you the similar expression like this in electrostatic. Be careful. You might deny at any times that what I've derived here is not correct. Be careful. So that's the formula, mathematical formula of relationship between gravitational field strength and gravitational potential. So again, we say that in physics or in mechanics, the quantity dV over dr is called the gravitational, it's called the potential gradient, not gravitational, it's called the potential gradient. Say with me, potential gradient. So today I taught you many terminologies. You have to speak them frequently. Potential gradient. Potential gradient. Okay? And then you have a question which we might be asking, what is potential gradient? What is potential gradient? What is potential gradient? I've told you, or I will teach you the terms known as pressure gradient, velocity gradient, in fluid mechanics. So the concepts of gradients in physics, we mean that a certain physical quantity divided by length. That's the meanings of the term gradients. We don't mean about the slope like in coordinate geometry now. It means about a certain physical quantity divided to the length. So we say that our potential gradient is a ratio of what? It's a ratio of gravitational potential, a ratio of gravitational potential, which is V to the what? To the distance, which you call dr. So gravitational potential, which is dV, and this one is dr. So if you mean that gravitational or potential gradient, this in physics we define as dV over dr. So mathematically, this is how we define this physical quantity. Okay. Again, I have to teach you about gravitational potential energy. I have taught you about the gravitational field. I have taught you about the gravitational field strength. I have taught you about the work done required to bring a body from the infinity to the point. I have taught you about the gravitational potential. And I have taught you about the relationship between gravitational field strength and the gravitational potential. And right now I want to teach you the sixth concept that we call the gravitational potential energy. Because according to the title, I wrote gravitational field, then gravitational potential, then gravitational potential energy. Okay, so that's what I have brought there. So right now, because you know the gravitational potential, you know the potential gradients, gravitational potential, etc., etc. Physics is beautiful. So now let me teach you about gravitational potential energy. Gravitational potential energy. So gravitational potential energy. So gravitational potential energy. So we say gravitational potential energy. Yes, so now we can call this one PE. Just like in other topics of mechanics, we used to learn about potential energy and kinetic energy. So the basic question, what is gravitational potential energy? What is gravitational potential energy? So that's the basic question that we have to answer. What is gravitational potential energy? So what is it? So gravitational potential energy of a body at any point in the gravitational field is amounts of work done in bringing the body from infinity to that point. So we say that gravitational potential energy in the gravitational field of a body. So the gravitational, so we say that the gravitational potential of a body in the gravitational field. The gravitational field, we say that is the amount of work done required to bring the body from infinity region to the point. So that's the meaning of gravitational potential energy. So gravitational potential energy is equal to the work done required to bring a body from that point. So gravitational potential energy is denoted by this and that. So this is the definition. So this is the amount of work done required to bring a body from infinity to the point. So mathematically, we say that, remember that according to the dimensions of work done is equal to the dimensions of potential energy. So mathematically we say that the formula of work done means that mathematically we say that we call the formula of work done in gravitational field is equal to the mass of the body times mass of the S times universal gravitational constant times radius square. No, radius itself, but should be negative. So work done is equal to gravitational potential energy, which is PE, and we have notations of U. So we say that gravitational potential energy, so gravitational potential energy, this is equal to work done, which is negative mass of the S, and then gravitational constant over radius. Okay? So we say that in physics, the gravitational potential energy is denoted as U. So this is as capital U. So we say gravitational potential in its symbol, which is U, is equal to negative. So gravitational potential is equal to negative mass of the body is mass of the S, gravitational constant over radius r. So this is the formula of gravitational potential. So if that is the formula of the gravitational potential, then we say that also, we remember that gravitational potential is equal to negative mass of the S, gravitational constant over radius. So what does it mean? It means that we can replace this part of the formula with the gravitational potential. So now we say that gravitational potential energy in terms of gravitational potential is equal to negative gravitational potential mass of the body. The SI unit of gravitational potential energy is joules. The SI unit of gravitational potential energy is joules. As a unit of gravitational potential energy is joules.